All right, so yesterday we had one challenge called Caesar Cipher. And Caesar Cipher is basically, it's kind of like a childhood cipher. Like I give you a like some sort of word or message that looks like nonsensical text. And then I tell you the number of places that I've moved. So when I give you what is string and I tell you to move forward 5, it turns it into this completely nonsensical text that your teachers in school probably don't know how to read. That's the goal when you're writing a very basic cipher like this. So we'll write it first. We'll do it in Ruby today because we did a JavaScript 1 yesterday. So first things first, I'm going to git clone from the web. Git clone downloads this from GitHub and brings it down onto my machine. You can kind of see in the background, there's that little folder that came out of nowhere. I'm just going to cd into Caesar Cipher, open it up in Sublime. Keep forgetting to download this. And let's kind of see what we get. So we have Caesar Cipher. I'm going to split the screen into 2 by doing Option Command 2, so I have 2 places to look. I have the spec file on the right, and spec just means test. And on the left, I have the Caesar Cipher. When I'm looking through this, if I give you, A, B, C, and I tell you to move forward 3 spaces, I'm going to get A, B, C, D, I think, if I'm not mistaken, D, E, F, like this. Yep. Okay. All right, so again, I give you a string. I give you the amount that you need to shift forward or backwards, and then you give me another kind of string coming out. So we understand what our input is. It looks like it's string and a shift amount, and our output's going to be what? Again, this is the first question you need to ask yourself all the time. What's my input, and then what is my output?
String.
Yep, so I take in a string and a shift amount, and I give out a nonsensical looking string, something like this. Now, before we start doing anything, how did you solve this inside of your head?
Counting.
By counting, okay. So A is the first letter of the alphabet, and then I'm adding 3 to it, so B, C, D. What do you notice about D? It's the 4th letter of the alphabet, right? So if A is the first letter of the alphabet, and I'm adding 3 to it, I can just quickly know that I can jump over to the 4th letter, which is D, and then I get to that point. So what happens if what if I give you X, Y, Z, and I tell you to move forward 6 spaces? What is the output at that point going to be? Okay.
Nonsensical characters.
What's that?
Whatever. Some nonsense. Oh, what you're not.
No, I'm just doing X, Y, Z, and I'm telling you to add 3.
CDE.
It's not CDE.
Is it ABC?
It is X, Y, Z, A, B, C, D. So it's actually D, E, F again.
Oh, 6.
That's probably a bad example. Let's do. I know I'm ending on D. Okay, C, D, E. I totally forgot how to count. How did you know this? Like you knew that once you got to the very end of the alphabet, you had to wrap around back to the beginning. So I have a few pieces of information that I know. I know that there are 26 letters in the alphabet. So these are the things I know. I know there are 26 letters. X is the 23rd letter. Y is the 24th. And Z is the, oh God, I'm stupid, 24th letter, 25th letter, and 26th letter. I know that C is the 3rd letter, and D 4th, and E 5. Right, is that Y, Z, A, B, C? Yeah, that's correct. Okay. So I have all of these pieces of information. Is there an algorithm that I can write using those mathematical pieces of information?
Yes.
Yes. What is Dan? What is the mathematical thing that you figured out?
I took the original position and then I added the shift.
Okay. So you're saying take the original position of the letter, and then you said add the shift amount to it, and then what?
And then subtract 26.
And then subtract 26. So I like, so for us, the original one here, like we have A is 1, B is 2, and C is 3. When I add 3 to it, I can just do D, E, F. I don't have to do anything fancy there. If I go to the end of the alphabet and I'm adding to it, I have to subtract stuff. I'm kind of, you kind of get where I'm going with this?
Right. So
what is the, I've been trying to think of one mathematical formula for everything.
I did 2. So I said if it's greater than 26.
Okay,
26.
sure. All right. So add it. If the result is greater than 26, then what?
Subtract 26.
Subtract 26, find the letter, and add that to the string. All right. Otherwise, I think we're pretty good, right? What if I give you A, B, C, and I tell you to go back 3 spaces like this, just -3?
Then I did another if statement.
Okay.
And if it ended up being less than 0,
Mm-hmm.
then I added 26.
So again, we start with X, Y, Z. Again, X is the 24th letter. If I add 5 to it, I get the 29th letter of the alphabet. But there's no 29 letters of the alphabet, so I can subtract 26 from it, and I get the 3rd letter, which is C. That's how I got to this particular point. Same thing with Z. Z is the 26th letter of the alphabet. If I add 5 to it, it gives me 31 letters. There's not 31 letters in the alphabet, so I subtract 26 from it, gives me 5, and that's this letter right here, this E. For A right here, like A is the first letter of the alphabet. When I subtract 3 away, I get -2. Oop, this is wrong. Let's see, A, Z, Y, X, X, Y, Z. So A is the first letter of the alphabet. When I subtract 3 away from it, I get -2. When I add 26 to -2, I get 24, which gives me X, because it's X, Y, Z. 24, X, 25, Y, 26 is Z. Does everyone kind of see how I figured the math out on this one? Because I knew I had to go forward and backwards. I didn't want to set up like 1,000 like if-else statements, so I figured there's probably some sort of mathematical thing. So I just listed out all the numbers that I had, and I was like, what mathematical formula can I figure out from this particular point? So we have an idea. We have some pseudocode. We're going to write the pseudocode out first, and then we'll just translate it really, really fast. So the more time you spend on the pseudocode up front, the less time you're going to spend on this later. So first things first, define a method called Caesar Cipher. Caesar Cipher takes in a string and a shift amount, the amount that you move the string forward or backwards. I'm going to create a hash with letters as keys and their position in the alphabet, which is an integer, as the value. I'm going to split the string or iterate over the string. It's up to you, whichever one you want. I'm going to split the string or iterate it over it to get an individual letter, and then I'm going to run this algorithm through it. Now we do need to, it looks like we need to keep track of exclamation points and capital letters. So I think we can, all we really have to do is, well, let's first, which one do you want to do first? You want to do the spaces? Do you want to do the capital letters? Do you want to do the symbols or anything like that? Let's do like the symbols. Okay, so basically once I split every single character, I'm seeing if it's a letter, then I can do this calculation to it. Otherwise, I just keep it the same. because you can kind of see this exclamation point over here, this bang symbol, remains the same on both. So if I see anything besides the letter, I'm just going to let it go. Just going to let it do its thing. So if the string, if the what do we want to call this, position? Because I'm going to iterate over everything. So it's like, yeah, if the character is not a letter, keep it the same. Otherwise, we're going to do this giant thing. Now I'm missing, we said that the input was going to be a string and a shift amount, and the output was going to be a nonsensical string. So it looks like I have to also create an answer string. If the character is not a letter, keep it the same, add it to the answer string. And then over here, we need to also add it to the answer string. All right, so we took care of exclamation points, spaces, periods, things like that. What about capital letters? How do we keep track of that?
I based mine on the Unicode, so that wasn't a problem. I had two sets of ranges, capitals and lowercase.
Okay, that's one way of going about it. What is Unicode? I'm sure you looked this up yesterday. What is Unicode?
I guess it's an underlying number associated with each character in the string.
Okay. Yeah, it's each key on a keyboard. Each key on a keyboard has a different value. Capital letters and lowercase letters have different values. Okay, John, what is another way that you figured out how to do this?
I did Unicode as well, but I guess you could do a check to say if this character is itself uppercase, then you know that you've got an uppercase character, and you can just pass that to the end of the string.
Yeah.
And then if else, then you know it's either a lowercase character or a punctuation mark.
Sure, that is one way of doing it. Does anybody else have another way? Okay. I'm just going to make it. There are many ways to solve this. You can do Unicode. You can have two hashes with all uppercase letters or all lowercase letters. I'm just going to have two hashes. It's not the most efficient way of doing things because I have to create another variable, but it's easy just to demonstrate for now. So I'm going to create a hash with letters, lowercase letters. Letters as keys and their position, and then create a hash with uppercase letters. Okay. If the character is not a letter, keep it the same, add it to the individual string. Otherwise, take the original. All right, first things first, we have to see, determine whether or not the letter is capital or lowercase. Take the original position of that letter in one of the two hashes created above. Add the shift amount to it. If the result is greater than 26, subtract 26, find the letter in that uppercase or lowercase hash, and add that number to the string. Otherwise, if it's less than 0, same thing. Add 26 to it, find the letter in that same uppercase or lowercase hash, and then add that to the answer. I think this is a fairly good place for us right now. I'm going to cut this real quick, put it here on this side so that we just have two screens so we're not scrolling up and down all the time. So I'm just going to go line by line, one by one. Define a method called Caesar Cipher. Done. Caesar Cipher takes in a string and a shift amount. Done. Create an answer string. So I know that I'm going to have an answer equals, this is something, just an empty string. Number 4, create a hash with lowercase letters as their keys and their position in the alphabet as the value. All right, so I'm just going to do lowercase hash or something like that. And I'm going to do A goes to 1, B goes to 2. I think
we'll way to quick fill a hash?
I feel like we're going to be here for a very long period of time. Yeah.
Could you just do an array instead?
Yeah.
What's that?
Just do an array so because it knows the positions of all.
Yeah, absolutely. You can definitely just do an array and then but then I have to do one more calculation because arrays count from 0 to 20. For us, it would count from 0 to 25 versus 1 to 26. It's not a bad idea. Don't get me wrong, but there's a bunch of like other built-in methods that you're going to find inside of Ruby. I could do it object literal. So I'm not going to go to a Ruby gem. Sorry, I'm going to go to Ruby array methods or something like that, because I know that I can have two arrays, one with all the letters, one with all the numbers. And if I can I like just like smash them together? Like that would be great if I could have like A and 1, B and 2, C and 3, and just smash them all together. That'd be really nice. I'm not really sure how to do that off the top of my head, so I'm just looking up Ruby array methods. Rubydoc.org is your point of truth for everything. I'm going to choose 2.4.1. That's the last big update. And you have all the methods here on the left-hand side, and you can kind of see any of them, if any of them stand out to you. To save on time, it's all the way down here at the bottom called zip. So what zip will do is essentially take one array, 4, 5, 6, B, 7, 8, 9, and I'm going to zip those together. I don't really know what this looks like, so I'm just going to try it out inside the console. Jump to IRB, paste these inside of here. I have A is equal to 4, 5, 6. B is equal to 7, 8, 9, A, zip, B, and I get 4, 7, 5, 8, 6, 9, but I have a multi-dimensional array right here. I'm not a big fan of that, so I'm just going to translate this into a hash, and then I have 4 to 7, 5 to 8, and 6 to 9. So if I'm not mistaken, I can do maybe letters equals A to Z. So I have all my letters here. Gives me, I start with the upper end of a range, lower end of a range, turn it into an array. Ruby kind of knows that people need the letters of the alphabet quite often. And then I'm just going to do numbers equals 1 all the way to 26 to array. So I get all the numbers as well. So if I just do letters.zip numbers.2h, I get that A equals 1, B equals 2, C equals 3, so on and so forth. So this is like, there's multiple ways to do it. I could have just hard-coded it as well. That's also fine. But I'm just going to grab this here. So I'm going to do the lowercase hash is going to be the letters from lowercase a to z. Turn those into an array. And then numbers, which is going to be 1 to 26, and turn that to an array. Now, I'm pretty sure this will work. Let's just copy and paste and make sure that this is the case. Yep, looks like everything works there. So I have a hash with lowercase letters. I'm going to do the same thing with uppercase letters. So instead of calling this lowercase hash, I'm going to call this uppercase hash. Turn these letters to capital A and capital Z. Just grab this whole line here. Just put your cursor anywhere on the line. Command C to copy, and just paste it in its place. So I have A is 1, B is 2, C is 3, and this is just like a Ruby shorthand way of doing it. So we've gone through the first 6 things, and now we're going to either split the string into an array and iterate over it, or we can just iterate over the string. It's up to you which one you would like to do. You want to just iterate over the string? Do you want to split it into an array? I agree with you. I don't see that there's any real need to split the string, because I can just iterate over each individual character. How do I iterate over a string in Ruby without splitting? Okay, let's take a look. I don't know. Let's say Ruby, how to iterate over a string. Iterating over a string in Ruby 1.8. Okay, we're a little bit further than that, but we can kind of see if there's anything that we can do. There's the question up top. There's an answer on the bottom. It looks like an each char. Okay, maybe we'll do Ruby docs string methods. Jump down to the 2.4 over here, and we're just going to look on the left if there's anything that kind of jumps out at us. We saw that there was a each char. Looks like we got something here. We have a string. We can iterate over each one of them, and then it looks like we have each character is going to be saved as the letter C. We're going to print C plus a space afterwards, and we get hello with spaces in between. So each char does work. I'm going to do string.each char. Let's take a look. Each char do, and we'll call this character. All right, so we did number 7. If the character is not a letter, keep it the same. Otherwise, add it to the answer string. And if it's not a letter, keep it the same. Add it to the answer string. So for real quick, we can just pseudocode this out for now, and then we'll figure out the exact syntax later. If character is not a string, is not a letter. Answer plus equals character. Otherwise, so which is every other case, else, we have to determine whether or not the letter is capital or lowercase. So I think I could just add else if character is lowercase. Take the original position of the letter in one of them, 2 hashes created above, add the shift amount to it. Okay? I have no idea where to get started with this. Anybody have any ideas?
I guess then this would be an iteration over the hashes to see what key matches, get the value of that key,
Okay.
Once you get the value of the key,
which I have right here.
You can get all ones.
Add to
All in ones?
The value equal that.
Cool.
All in one. You're saying you break them up.
Like that. I agree with that, sure. So the value is, so if I give you the letter A, right? If the letter A, it's going to exist in the lowercase hash, and it's going to give you 1, and the value is going to be that plus the shift amount, not 26. All right, and then you said if the result is greater than 26, I'm going to subtract 26, find the letter in that uppercase or lowercase hash, and add that to the answer string. So it's just going to be answer plus equals, Jesus, lowercase hash value at, I don't know, value minus 26, something like that. Does that kind of make sense? So if I give you the letter Z and I tell you to add 2 to it, you obviously know in your mind that the letter is going to be B. So with the value of Z is going to give me 26, and since it's greater than 26, I'm going to find the new value is going to be that, that 28 number, subtracting 2 from it and finding the letter with the value of 2. That gives me back, takes me back up to B.
But then that would just give us, let's say if it was Z that we got, and Z is the number 26, and we're adding 2 to it. It's greater than 26. So you get 28. You subtract 26.
Yep.
We'll get 2.
Yep.
But it'll just return 2. So
that's why I'm doing this like value add. I don't think this is an actual method yet. So like before we saw that when I see this number 2 right here, right? So if I find a value with 2 in it, I'm just going to take the key at that particular point. So
is that what the value add does?
Yeah, I don't really know if this is a method. I'm pretty sure this is not a method.
Okay.
So that's basically what I'm trying to do. So if I give you the letter Z, which has a value of 26, and I tell you to move forward 3 spaces, it's going to give you like a value of 29. But 29 is not the 29th letter of an alphabet is the 3rd letter of the alphabet because I have to subtract 26. So I find a key value pair where the value is going to be 3, and I just take the key and I add that to the answer.
Okay.
That's what I'm doing here.
Is it going to be easier to find if you reverse your keys and your values?
It could be. Yeah, it's up to you. I think there's probably a method, and that's why I called it value at. Actually, let's just look it up. Hash methods in Ruby. Most of the time in Ruby specifically, if you think, wow, I wish there was a method for it, there's probably a method for it. In JavaScript and another language, they're not quite as nice to you, and for good reason, because there's a lot of magic that's just happening here, and you never really need to know what's going on underneath the hood, which is okay for right now because we're still thinking about how to think through algorithms, but down the road, people are interested in, can you build the tools rather than can you use the tools? So I don't know. I'm just looking here on the left if there's anything that stands out to me. It's each key will iterate over it, but I'm trying to find something.
Has key.
Has key will return true or false.
It's up there.
This one?
Yeah.
This one's going to just return you true or false. So it doesn't, unfortunately, won't give me that. I think it's down here. Values at cat count, no. Key at? All right, I don't know. Ruby, have value, find key. Let's look it up. How to find, looks like someone else asked this question. It looks like I have a hash. Is there a quick Ruby way to obtain the key given when I give you the client ID? Looks like there's an enumerable method called select. All right, let's take a look at what this says. All right, looks like select takes in an object. Let's take a look at their answer over here. So when I select, let's just take a look at Ruby select by. Let's take a look. Looks like there's a select where if I have a, and this looks like it's an array, it's probably not very useful for me. I think there's a value over here. Let's find out. Lowercase hash value of 23. There's no.
That's not it. There's one with dot values.
There is a dot value. Let me do something real quick. Uppercase hash dot value 33. You were saying something about flipping around the numbers?
Yeah, just have the numbers be the key and the letters be the values.
We could do that, yeah. Let me do one thing real quick. We just get an old answer just so we're not banging our heads forever. This is one way of doing it. I'm going to just kind of read through this for now. I'll send this one out, take a quick break, and then we'll get into like new material for today. So again, at the very top, I just have require pry. Pry gives me, brings in an external library called pry in, which gives me different breaking points. So what I'm doing here is I've got this my empty output. Remember, there's that answer empty string and then the final empty string here at the bottom. I'm splitting it. I probably shouldn't do that. I should probably just do each character, each char. So I'm iterating over each character inside of the string. And there's something built in that we're going to talk about today called regular expressions. So this is kind of like a taste for it. Basically what we're doing here is so basically I'm saying this particular character, like the letter A, B, C, or whatever, if it matches anything in the range of capital A through capital Z or lowercase a through lowercase z, if it matches and it equals nil, so it's not a capital letter or a lowercase letter, I'm just going to add that particular character to the output string. Sean?
This should work in Ruby, right? It could be uppercase A with lowercase a.
Yes, I'm saying if it's not a letter. This is basically testing if it's not a letter.
But I'm saying like you could write a capital A dash lowercase b, would make you do the entire range.
Possibly. This is one answer. We can test that one later. So if it's not a letter, this equals nil. I'm going to just add that. So I'm talking spaces, periods, exclamation points. I'm just adding that to the output. If it's an uppercase letter, I'm going to do output plus convert letter, which I created a separate method down here, where I'm going to downcase the letter, give it a shift amount, and then upcase it on the way out. So I don't care about uppercase or lowercase. Before we had uppercase letters and lowercase letters, two different hashes. I'm setting them lowercase letters to begin with, and I'm just going to uppercase the output on the way out. So let's take a look at convert letter. I got that letter in the shift amount again. So I've got letters and values, A through Z, kind of zipped together with 1 through 26. The current value is going to be letters and values, which is that A through Z with this particular letter. If it's greater than 26, I'm going to find the key. Oh, I guess that was the answer. It was just .key. I'm going to find the key at the current value minus 26. Again, this is if it's greater than 26, so I've got the 28th letter in the alphabet. I'm going to find letters and values, which is this. It looks a little something like this. I'm looking for the key at 28 plus the shift amount, current value plus shift amount minus 26. So it would give me the second letter of the alphabet. If it's less than 0, then I'm going to add 26 to it. Otherwise, if it's just like a regular letter inside of the alphabet, I'm going to keep it the same and then just pass it over. From here, I get one individual letter. I'm going to add it back to the output and then keep going through each individual character until we get to the output. Let's just see if this runs. CD into Ruby, and just Ruby, Caesar, Cipher, spec. And we get hopefully a bunch of trues. True, true, true. So we were close. It was just .key. My mistake. Yeah. All right. Let's take a 8-minute break till 9:50. We'll cover some new material, and we'll get started on today.
Yeah.